Just remember what the MPAA says. Horrific, deplorable violence is okay, as long as people don't say any naughty words. What?
So here's a good one. Say you're working on your short film and a lot of people are getting shot, and you, like everyone else on the internet, bought Action Essentials from Video Copilot. And now that you're on the 30th person in a row getting shot up in your clever little short film, you're noticing that all the blood hits look exactly the same. So then you go online and you're like, I'm gonna buy some better ones. Then you find out that most of those suck, and you keep heading down that road until you realize that there's not a lot of options when it comes to making unique, specific blood elements. Say you wanted to fly out and hit the wall. Say you wanted to go all the way down and hit the ground, and what you're gonna run into is stuff like this. You're gonna look at the element and realize that it's really close up. Usually the spray flies outside of the bounding box and completely disappears, and when you try to comp it into your scene, it just doesn't fucking look right, and you have to be really creative, and it doesn't give you a lot of flexibility. And not only that, but Andrew Kramer teased a 4K Action Essentials pack fucking years ago, and that shit is still nowhere to be seen.
And some amazing 4K dust elements
from a secret new collection.
When's it coming, Andrew? Don't fucking tease that shit to us and then not deliver. Fucking years go by. What the hell? Deep breath. Well, I'm here to save you. So this is going to be my tutorial on how to create your own CG blood elements inside 3D Studio Max, so you don't have to rely on shit like this. So let's get started. So like all my other tutorials, I'm going to start off by opening up 3D Studio Max straight out, no prep, no nothing, and I'm going to show you how to do this from the ground up without any prep, and hopefully not miss any details in explaining to you how all this works. Alright, now that Max is up, I'm going to close this down, and I'm going to open up my test file, which is just a simple 3D model of a guy right here. And here we have our test scene. Now, for expediency, because simming blood can take a long time, just to prepare you, simming blood can hurt really bad, depending on what your settings are, what you want to do with it, all kinds of stuff. Simming all liquids is a long, painful process, so just prepare yourself if you're getting ready to go down this road. So all I'm going to do to change this scene is I'm going to move this plane all the way up, and I'm going to make the blood shoot out of his chest and onto the plane. Now, if I wanted it to fly out and go all the way down to the floor where his feet are, it would be a much longer sim. This is for tutorial purposes, so I'm going to keep things kind of short and concise. Alright, so the next thing you're going to want to do is try to design some kind of emitter. An emitter is basically any piece of geo that you can stick somewhere that you want the blood to fly out of. Now, you can cut a piece out of this guy's chest. I don't like doing it that way. I like to have it very simple and assume that you're going to put this over the top of like live action footage. So I'm going to create a cylinder, draw it out, and in the top of the caps, I'm going to give it a few segments. Nothing crazy. All right, collapse it down, and I'm going to grow this guy out, Control Invert, Delete. So now all I have is just a circle with some segments on it. Pretty simple, nothing crazy. And let's move that anchor point to the middle. So that's going to be my emitter. And essentially all you have to do is just kind of line it up wherever you want it to go on your guy. Now this is going to be where the blood shoots out of, so just keep that in mind. One thing that I'm going to do as well is I'm going to put an edit poly over the top of this guy, so I can manipulate it around and not really destroy the base model underneath. This will allow me to like scale it and rotate it and do all kinds of stuff. Alright, so there you go. And there's our little bitty emitter. That's going to be shooting the blood out of this guy's chest. Now, the program that I'm going to be using to create this blood is called Phoenix FD, and I'm just going to assume that you don't know anything about Phoenix FD. So let's go right from the beginning on how to set this guy up. The first thing you're going to do is you're going to click on Standard Primitives right here, and you're going to go down and you're going to see Phoenix FD as an option. Underneath Phoenix FD, you get PHX Foam, Fire Smoke Sim, Liquid Sim, and of course, we're going to go with a Liquid Sim. And this is a bounding box, so you're going to draw it out like this, and when you look at it from the side, it's going to look like that. It's just a little bitty box, and this is going to let your program know that this is where the liquid's going to come from. So any emitter that's inside this object is going to spout liquid, and we can move it over and put it right where it needs to go to make sure that your little bitty guy is going to be inside of this box. All right, so now that we got this thing drawn out, we need one more object in order to make it final. And that can be found underneath helpers, underneath shaded. There's a Phoenix FD, and we're looking for a liquid source. And when you draw it out, it's going to look like this. It's going to be a little bitty like ocean wave guy with a couple of circles. And you can kind of draw it anywhere, but it's going to be like weird in space. So I'm just going to snap it to where everything else is. And you can already see that it's like really big. You can scale this guy around and do whatever. It's not going to appear in any of your renders. So you don't have to worry too much about it. You just put it off over here. And this is going to be the first thing that we set up. All right, so these are the 3 basic building blocks that you're going to need in order to get this ball rolling. Now, the first thing you're going to want to do is freeze this guy so he doesn't give you any trouble, freeze the ground. You're not going to need to ever select those 2 guys. So you select your liquid source, then you have to go to your emitter nodes and then add whatever you want to emit. So, of course, we're going to add our little cylinder guy. Now, one thing to know about creating geometry is that it runs on normals. So what that means is essentially one of the main reasons why I created a cylinder and deleted away the body is because the normals on the inside of it won't read. So if you create a sphere, just as a rule of thumb, if I create a sphere like this and convert it to edible poly and then grab a bunch of stuff like this, Control I, delete. What this means is that the normals on the outside of the surface right here, if I were to emit liquid, would emit. Anything inside down in here, anything on the inside of the sphere won't emit anything. And that really helps you because it allows you to control what direction the blood is going to shoot out from. So that's just a little thing to keep in mind. It's not that big of a deal, but it's something that I feel like you should probably know. All right, so back to it. Always be sure to save, by the way. Here, just as a warning, simming liquid is very time consuming, it's very hard, it's very taxing on your machine, so save often. But now, since we have this thing set up, the first thing we can do is take a look at some of these parameters. Now, the first one that you're going to see down here is outgoing velocity, and it's default to 50, which is a decent number to start as. So what I'm going to do is I'm going to go to frame 5, I'm going to turn on auto key, which is in, or you can just turn it on by clicking it down here. And I'm going to just make that guy 50. It's going to set a keyframe, which is what I want. Now I'm going to come to 1 frame before, and I'm going to set this guy to 0. Delete this frame in the beginning, 0 to 50, and then we're going to go back down to 0. Now what that's basically doing is for 1 frame, much like a gunshot wound, it's going to just explode a liquid out. And you want it to, unless you want it to continue to bleed afterward, and maybe we'll do that. We'll turn our auto key back on, we'll set this guy to 2, that way it'll keep bleeding throughout the rest of the 30 frames. Additionally, what I'm going to do is I'm going to turn the noise up. And noise just kind of adds a little bit of flavor to it. You don't always need it. It's probably good to experiment a little bit without it. But just as a rule of thumb with gunshot wounds, because they're very fast and violent, I like to turn the noise up to about 2 and just kind of see what that gives me. And then there's our parameters. We're going from 0 to 50 to 2, and our noise is at 2. And we already have our emitter selected, which is this little guy right here, cylinder 1. And that's really all you have to do with this guy, unless you want to change anything or have it be a little bit more specific. And then we can move on to this little pink box where shit's about to get real complicated. Now, the first thing you're going to notice is that when you select on this guy, there are a hell of a lot of tabs going on right here. And this is a whole lot of stuff that you're not going to have to worry about, but don't worry, I'm going to walk you through each one that's most important to you in getting this specific task done. When you select simulation, it gives you a start frame and a stop frame. Now, this is really important because you already know that your sim doesn't really start until the keyframes on this guy start, which is frame 4. So you can already say frame 4, bam, and then you can move it to the end of your timeline, which is going to be frame 30, and you know that that's all you're going to need. And then, like all things, save. So that's pretty well set up. You don't need to worry about this too much until a little bit later. So resimulation doesn't really matter at this point. Grid, all right, so this takes some explaining. What grid is if you zoom in, you see these little ticks on the side of this guy. And that is the overall detail level of the blood. That is determined by the total number of cells inside your scene. This can get really complicated. It can roll into a lot of scene scale issues and a lot of bullshit. But basically the gist of it is the more fine you can get these ticks, the better your blood is going to look. And you can just increase the detail, and as you increase the detail by clicking on this, you can actually see the number of ticks increase exponentially. It kind of doubles every single time. We're getting up into the 700,000th at this point. That's really, really high. I'm going to start off in like the 190,000 range, because that'll be good to get a few sims kind of rolling. It tells you what the overall cell size is, tells you what your boundary box size is, all that stuff. Now, if I were to hit sim right now, come up to here under simulation and go start, like most people would, this happens. You're going to be like, what? I don't really see what I'm dealing with here. Like, this is kind of weird. So it ran the 30 frames, a bunch of stuff poured out, and you're like, oh, okay, cool, but I just can't see if this is good or not. Well, one way to see if it's good or not is to come down here underneath preview. And underneath preview, there is auto reduction and show mesh. Auto reduction is going to be automatically checked. No problem. Just leave it as is. If you click show mesh, there you go. There's your blood. Now, what you're going to notice is that it looks like crap, right? It looks like crap, and it's not making it past the boundary of this box. The second it hits the border, it completely disappears. That technically is what you want to happen right now. So what most people would do next is they would just make the bounding box bigger. You just come under here and X, Y, and Z, and you start, scaling this guy out in all directions. But what you're going to notice is this number jumps up exponentially when you start doing that. So just as you make the box bigger, it needs more cells to fill it up, which means this number gets higher and higher and higher. And before you know it, you're going to be in the millions. So a way to avoid that is to kind of have an idea in your head where the blood is going to go and what it's going to do. Because you don't need to make this bounding box any bigger. There's an option right down here called Adaptive Grid that's going to take care of that for you. Now, Adaptive Grid, when you turn it on, I usually give the extra margin about 3. That's a little bit of a cushion that it gives you. That's not really what matters, though. What you want is no smaller than initial grid to be checked, and then you want to click maximum expansion. Now this tells you what the max cells are right here, and they should be exactly the same number as the bounding box currently is in size. But since I know this is going to shoot out and away from the body like this, I can start playing with these numbers and you'll see a red box starts to appear. Now the red box is essentially going to be where the blood can go. Not where it will go, but where you think it's gonna go ultimately. So I'm gonna raise this up and I'm gonna push out these borders a little bit, and doesn't really need to go back at all, and then I'm gonna push it forward because I am going to assume that when I turn this on, the blood's gonna go out like that. Just a gunshot wound. And that's gonna be my assumed bounding box, and you want to give it some cushion because this stuff can tend to go everywhere, much like in real life. So this means the next time that I sim, it's going to start in the green and ultimately fill up the red depending on how much of that space it needs. And you can already see right down here that my max cells have reached 10 million. That's a potential number. That's how many it can possibly reach based on what this liquid does. Now that that's set up, save like always. We're going to go to simulation and we're going to hit start and see what it does. All right, cool. But it still looks like crap and it's doing a lot of weird shit. So you can see here it's kind of spreading across the floor like water. Also, this is really taxing on your machine, so do your best to scrubbing around these high quality sims are going to be really, really tough on you. You can come down here and you can turn off the particles, which are these little bitty speckly bits that, if I just turn on 2D pan and zoom out, I'll come in here and you'll see these little bitty white dots all over everything. Those are basically particles that show that it's generated. You can turn them off. I feel it clears up your viewport a little bit. But it's not really acting like blood, right? We're not there yet because we haven't really played with anything, and you know, like it's just not there. So save this guy and then we'll start talking about why it's not there. But first, an important thing. Underneath output. Output right here is where your cache goes. Now, I have a folder right here. Basically, it will create a folder automatically on wherever your scene file is. So since my scene file is right here on my desktop, it created a folder called Blood Sim Max Phoenix 2 frames. And if you open this guy up and you see, these are my sim files. This is every frame of cached liquid that it has created to create that animation. And these are really, really small because my details are not very big. But as your blood gets bigger, these things are going to be 10, 20, 30, sometimes 100 megabytes a piece. It's really good to keep that in mind if you're space conscious. I didn't mention it in the beginning because I knew it was going to create that and I wanted to show it to you now. And additionally, you can put this anywhere. You can delete the cache file, reset the default, show file name, you can browse. You know, here it is right here, and underneath browse is how you load in different caches. Say you sim 3 or 4 different blood caches, and then you want to load them each in and render them individually, you can totally do that here. You just double click on it, loads it right in, should be fine. But you can save it anywhere you want. So just so you understand that. Next, since output's all set up and it's got a place where it can live and everything's going to be great, we're going to go into dynamics. Now this is the nitty gritty. Right? This is where all the magic happens inside here. And it's going to be hard to kind of explain what each one of these does. There's a really, really good document that Chaos Group has on their website that kind of like gives you video examples of what each does and everything. But what I'm going to need it to do is to look at what blood does and how it reacts naturally and what you know about the viscosity level and the thickness and the contact of blood and try to apply it to what you see here in 3D. Now, what I know about blood is that it's really thick. It sticks to things really well. It's like corn syrup in a way, which means it's thick but not too thick. It's you know, it's got this sort of quality to it that's like a little bit higher than water. So as we're moving forward, we're going to try to achieve that. Also, like you'll notice that when you throw a thick liquid around, like it kind of turns stringy, like it tries to keep itself together as it flies through the air. Blood does that a lot. Blood has a lot of properties depending on where a person is shot. It can be thick and streamy. It can be really cloudy. Depending on what you want, you can get almost everything you need out of these settings. Now, the first one that we're going to mess with is steps per frame. Now, steps per frame will try to maintain the connectivity of the liquid particles. And you can see right here, it's at 1, and all of this stuff is like breaking up a lot. Some of it tries to stay together as best it can, like you'll get sections like this, but then you'll get all these dots that kind of just break off and do everything, and it's just not what blood really looks like. So I'm going to take this guy to 7. Now, why did I take it to 7? Good question. Like all this is kind of like weird. A lot of these numbers don't really make sense. Some of them are really, really sensitive. Others aren't. So what I'm going to do is I'm going to set this to 7. Hopefully it will change the look of this blood. So I'm going to go ahead and save my scene file. And I'm going to sim it again with a step number of 7. And then we're going to keep in mind what this looked like right here, which is it breaks up a whole lot. It's kind of chunky, and all this stuff just looks not very awesome. So let's sim it. So I'm going to go and stop it right here because I've already seen everything that I need. If you come to this frame right here, you can see how this thing really tried when it was flying through the air to keep its shape, and that's exactly what I want. So switching it from 1 to 7 was a good call. Now that it's got this kind of stringy nature to it, I can play around with a few of these other things and try to get the ball really rolling, and then when I feel like it's looking pretty good, I can jack my settings up and give it a nice good long render, and we'll see what we get. So like always, save this guy, and the next thing we're going to mess with is, so viscosity and non-Newtonian are here. Those are pretty cool. I'm not going to mess with those because they're for making extremely thick, kind of goopy things. You're talking like chocolate pouring over a strawberry or some shit like that. You know, it's extremely thick, you know, so it's not going to have the sort of like breakup that I'm going to want here. So we're not going to mess with those, but that's essentially what they do. They work in conjunction, and if you want to see really good examples, again, go to the Chaos Group site that I have in the description, and it'll show you exactly what they do. Surface tension. Now, this one's pretty important. So surface tension is another way of assisting the sim in how things break up when it flies out, essentially. The surface of the water will stretch to a point before it actually breaks. Now, you're probably saying to yourself, well, fuck, that sounds a lot like what steps per frame does. And yes, that's exactly true. That's how you get really confused in here, because while steps per frame, I can jack that sucker to 7 and it'll look really good, surface tension is really sensitive. So 0.2 on this guy, and you're going to notice a difference. Maybe not so much of a difference because the detail in my sim is really low, but you will notice a difference. I'm going to put this guy to 2 just because I know that that's a really good way to get this thing rolling, because I know that that's going to help me down the road. I'm not going to do another sim because you're not going to see the effects in this level of detail very much. Now, the third thing is right down here in wetting. Now, wetting is a whole thing, but essentially what you know about blood is that it's sticky. Blood will stick to a surface, especially if it hits clothes, if it hits anything, it'll leave it there. Now, there is a way for wherever blood hits on a 3D object to create a texture map. I'm going to make a different tutorial for that because it's a lot to explain. But for right now, I'm just going to show you what these do. So when you turn wetting on, because you actually have to activate it, it's off by default. You have stuff that makes a lot of sense. You have consumed liquid. So as a liquid pours over a surface, it will eat up and disappear. Now, I don't want to do that because blood doesn't normally do that. So I'm going to turn this to 0 because I don't want it to happen. Drying time is basically if you want a liquid to evaporate. You can set how long it is. It's default to 10,000, which means you're never going to see it dry in a scene. You can essentially set that, but since it's blood, I don't want it to dry. I want it to stay on the entire time. Now, the last one is the most important because it's sticky effect. This is how you get blood to stick to objects, essentially. I'm going to set this to 1 because I want it to stick as best it can to any surface. Now, what you need to know already is that Phoenix as a liquid simulation program is kind of on the lower end, so it's not very accurate. It does have problems. It does have bugs. You will run into some spooky shit that you can't really find an answer for. There's documentation, but not a lot for if you run into like really serious problems. So just keep that in mind moving forward. You know, you'll be like, I want it to stick 100% and it's set to 1 and it only goes to 1. So anything it touches, the blood should stick and stay because it's not being consumed and it's not drying. Let's add a 0 to drying just in case. That can only goes 10,000, fuck. So it shouldn't dry and it shouldn't consume and it should stay wherever it sticks. But you're going to notice it's probably not going to do that because that is just a drawback of having a lower end liquid simulation program as opposed to a higher end one like Houdini or, you know, RealFlow, something like that that's much more suited for this task. This is a sort of poor man's way of going about it. It's also faster and a lot more user-friendly, truthfully, and you don't need to know another entire complex-ass program in order to get it done. So moving on, I'm going to give this thing another sim. So we're going to save it, and we're going to hit sim. And see what happens. All right, I'm going to stop it right there because I can already see that this isn't what I want. Turning this guy up to 2 made that kind of difference between my sims. So I'm going to put this guy at 0.05, and I'm going to put this guy at 6, and save, and we're going to go again, because I want a nice stream, but I want breakup as well. This is a way too connected, and you can already see right here, because it's sticky and thicker, it's like really struggling to pour down this guy. Now that's more accurate, that's closer to what blood does, but I want a little bit more breakup, so let's give it another shot. Stop. All right, cool. That's much, much closer to what I'm looking for. So if I select this guy off, you can kind of see what's going on. All that looks really good, and now we have to get into the painful part of this whole process, which is dialing up the detail and seeing what that does, because what a lot of people don't seem to tell you is that when you sim something with a certain level of detail and then you jack up your detail assuming it's going to keep similar properties on the next go around, you'll realize that the blood acts completely differently the more detailed it is. I just start small with a lower detail so I can sim faster and then work my way up to the higher detailed stuff. This is just to demonstrate to you what this process is like. So next, we have to just jack our detail up. So we have 200,000, and we're going to go big. We're going to go to 700,000. Save this guy, and this is where it starts getting hairy, right? We're at 700,000 total cells, but we're at 32 million potential cells in terms of detail once it fills out this box. So you have to keep that in mind. These sim times are going to go up higher and higher and higher. So be wary. Also, when you get to the later part of your sim where it is using, tens of millions, and in some cases, 100 million, 200. I mean, I've gotten sims up to like 500 million because crazy shit's happening. People are running down the street like chopping heads off. It's gnarly, right? Always be memory conscious. I'm working on my personal computer now. This is, I'm not on a supercomputer, and I'm being aware that I have technical limitations. I can't just kick this to a farm and let it run and not worry about it crashing. So essentially what I'm ready to do now is give this guy another sim. So I'm going to save. All right. And we're ready to go. Go to simulation, hit start. All right, let's stop. Now, what you're going to notice here is even though I had really nice breakup in my previous version with the lower simulation, it really kept its shape moving forward. Now, there's a couple of ways to combat this. But one way that I'm going to try doesn't involve changing my parameters at all. What it's going to involve is changing my emitter. So I'm going to go to frame 0 where there's no blood. I'm going to zoom in on this guy, and you're going to see that this guy's really uniform. This guy looks really, really uniform. It's just a perfect circle, and it's completely flat. So when you start changing this guy, you're going to notice that the blood will start to act differently. So what I'm going to do, first off, is I'm going to delete away a few of these polygons. And this will add a little bit of variation to what shoots out of this guy. So we're going to just delete those guys. And remember, we're in an edit poly, so all of this is undoable. So then I'm going to select all these guys, and I'm going to put an FFD on here. And I'm going to change the shape a little bit. Just bow it a bit. Nothing crazy. And then make sure you move it back to the shape of the body. Because this emitter doesn't ultimately matter all that much. I'm kind of just freeballing it because, that's how it goes. And move it to here. And make a camera. Okay, so now I'm ready to give this guy another sim, and because we're still in the experimenting phase, we're just going to see what it does. So hit play. Oh yeah. All right, let's stop it, and we're going to hit save, and I'm going to say that that looks pretty solid. Like, that blood flies out of there, keeps its shape, speckles around, does all sorts of crap. There's lots of good variation in it, and remember, this stuff is supposed to be really, really fast. Now, here's the thing about this. Since we had this emitter that was still running at 2, it's going to continue to pour blood out of this wound. So what I'm going to do now, because I don't want it to continue to do that, is I'm going to come here to this last frame. I'm going to set this guy to 0, hit N, hit save, and because there's a lot of breakup going on here, you got to remember that when you render this thing, it's not going to look like this at all. Like, all this is going to be motion blurred out, so all these little specks are going to become that spray that you know so well when blood shoots out. And the strand that I'm trying to maintain in the core of this is the blood that you actually see fall to the ground. What I want is a little bit more stringiness, so what I'm going to do is I'm going to come down to my dynamics, and I'm going to change this to 8. And I'm going to save, and I'm going to prepare for the next sim. So let's move my camera off to the side a little bit so we get a better idea of what we're dealing with. And I also want to make sure that it doesn't hit any of these boxes. So let's actually increase a little bit of the size. Not that one. There you go, that one. And that out a little bit. Nothing crazy. Truthfully, I'm going to go to my surface tension. I'm going to change it to 0.1. Change to 0.1. Why not? Let's just get crazy, right? But you got to keep in mind that little changes in these numbers will have big effects on your blood. So let's just give it another go. All right, I'm going to stop it there. Hit save. And now I think it's a good time to make a preview of all of our good work here. So making previews in Max, I'm just going to assume that you don't know how to do it, and I'll show you how I go about doing it. So if you hit this plus right here, you can go to Create Preview and then Create Preview Animation. Additionally, Shift V will get that done, but you know I'm in the habit of clicking. So right here is your percent. You can change the dimensions. Oddly, you can never get to 100%, which is kind of stupid. You can turn stuff on and off depending on what you want to see. You can give it a mode if you want to look at it in a specific way. I'm going to go with realistic. Move this guy over. And right here you have two options. Now AVI is for no one because Jesus. What I'm just going to do is a JPEG sequence. So I'm going to go to File. I'm going to change it to JPEG. Go to my desktop. Find my blood sim folder, create a new one called blood preview _ grab the name, double click, paste, save, OK, and then hit create. And we'll see our blood do its work. Also, it's going to make a preview of the entire timeline unless you adjust the frames. So it's probably going to change because I was messing with the sim. So this is actually a good way for you to see what it was doing as opposed to what I ended up with. So this right here, oh, additionally, if you want to know what player this is DJV View. It's a free app that will automatically play files like this, image sequences. It's really good. It's super handy. It'll keep you from having to load it into like Premiere or After Effects or something. You don't have to pay a dime for it. But you can see what this does. It shoots out really nice in a good spray. They disappear when they hit the wall, but you know, this is for testing purposes. And then it keeps a nice core in here as it comes out, and then when it hits the ground, it stays like real blood does, and then the blood just kind of like drips and oozes. And then you see the previous versions, which were doing this shit. They were like beating across the floor like real water, and it was all chunky and gross. But now our sim's looking real good. You can do other stuff. You can get more extreme with the shape of your emitter because this is still coming out generally together. If you want it to be more of a wide kind of spray, that's just as easy as going back into your scene, going to this and getting in on this guy and changing his dimensions to where he'll really kind of like bow out. So if I grab these FFDs and start rotating them like this stuff, and really, really get extreme with this, like this. Make sure it's not intersecting. Come back to here, save, and I'm going to sim again. And we can stop there. Cool. So this is already looking much better. The spray is much wider, so let's go ahead and run a preview of this. Create preview. Create, should save everything, do not message me again, overwrite those frames. Bam. So look at that. Looks pretty good until it switches to the crap part. So I would say, barring anything obvious, you know, like it flies up here and it's getting clipped at the top, which means I would need to raise this up a bit. And naturally, they get clipped when they come out here, but honestly, I don't need that for the purposes of this tutorial. I'm going to raise up this top, and then I'm going to give this a legit sim, and then I'll show you how to render it and make it look like real blood. All right, so let's close this guy down, hit save, make sure everything's good, grab our bounding box. We're going to come up to our dimensions, and is it Z? Shit, I can't remember what these ever are. The base? Yeah, the base doesn't matter. Doesn't matter. Doesn't matter. There we go. Go up a little bit. Something like that. All right, so we're going to save, and then I'm just going to let this bad boy run all the way to the end, and it will overwrite the other sims, so we won't have to worry about them. Let's do it. Cool. All done. Save. Alrighty, let's run another preview. Create preview animation, create. Nailed it. Cool. All right, all that's looking really good. So there is one additional thing that I can show you about this blood before we get into any sort of like lighting and rendering and all that stuff, is that if you get really in on here, and of course, depending on how close or far you need to get from the blood would entirely depend on your cell count. So you're seeing here that 700,000 isn't a lot, honestly, once you get this close to something. If you're doing extreme close-ups of blood, your stuff's going to be in the 30 million range. So just be aware. But additionally, where the give and take comes in is that if you're this close to the blood, your bounding box doesn't need to be this big, right? If it's this big, like, then the blood, its detail gets consolidated, and it's kind of a way that it like creatively solves the problem. So you don't have to have hundreds of millions, even though you can easily get to hundreds of millions of total cell counts. Like when you start looking at a number down here that's like 51.9 million cells, and that's like a quaint little number. That'll be what you start with in the long run. So keep that in mind ultimately, because this stuff can get pretty fucking crazy really fast and can be really hard on your machine. And if you have a weaker machine and you're trying to sim this stuff, then you end up crashing a whole lot, and you're just going to hate your life because you bit off more than you can chew. But say you come to a frame where the blood's like flying through the air. Let's try to find one. Like this guy right here. Blood's sailing through the air and it looks pretty good. You can actually adjust the blood after you've simmed it just a bit. Not a crazy amount, but you can play with it. So if you come down here into rendering, there's an option right here called Mesh Smooth. And then you have smoothness, use liquid particles. So if you turn this guy on, use liquid particles. So if I go to my smoothness and I change that to 10, you see what it did to the blood here. Like it completely ate into the blood and like, oh my god, did all kinds of weird shit. So you don't want to go to 10, maybe 2, something like that. You can look at the difference, like here's 0, right? And it's, so if you're looking at areas like this, you can see that it's kind of chunky. You can see a little bit of the geo that's happening inside here. So we're going to change it to like 3. Way too much. 1. No difference. 2. Nice. 3. Yeah, 3 goes crazy. 2 it is, because this shit gets touchy. Ultimately, it's just a way to kind of smooth and just make the blood look a little bit better in post. It's not going to make a huge difference if you're really far away. In fact, it probably won't make any difference at all. So it's just another option to play with. That's for extreme close-ups on blood. If you really, really need to see it and have it look nice, again, your total cell count, being able to smooth it in post, all that's going to look really good. So now let's just get on to let's just do a little quick render test of our blood to make sure that everything looks good and feels right and that we won't have any problems later on. Alright, so let's just slash something together real quick here and see what we get. So we got our blood here, and I'm going to make a quick little material for it. And I'm just going to make it a standard, and I'm going to make it really, really red, like a deep, deep red. Something like that. And I'm going to spec the hell out of this thing. Like, oh, so much spec. Just not giving a shit. Alright, and we'll apply that bad boy. And let's create a V-Ray light. Plane. Totally fine, and we'll put one like there, and there. Raise them up. Come back to here and do a render. Alright, cool. You know, like you can play around with all these numbers. This isn't what the tutorial is really about. The real life rules apply. Blood has spec. It's very, very dark red. It just, again, depends on what you're doing for. I'm just slapping this together so we can put together a test render and see how it looks ultimately in the end. Alrighty, and let's do one last thing. V-Ray light. And we're gonna make it dome. Into here and 0.25. Alright, whatevs. Don't need to test that anymore. And now I'm going to render a sequence. And I'll get back to you when the sequence is done. Alright, let's see all our hard work. And that's what it's all about. Now, a lot of things to keep in mind about something like this is that my samples aren't very high. You could always go bigger, you could always go better, you could always have more blood. Things to keep in mind too when looking at a preview render of blood is that a lot of this stuff, I mean, this is on like a flat gray background. Like whatever you put this blood into, a lot of this shit is going to go away. A lot of these little bitty specks and everything, they're going to become almost invisible because they're motion blurred, like flying past trees or traffic. Whatever scene is going to be in the background of your shot, this blood's going to blend into it, especially after you color correct it and get it looking fairly nice. This kind of action that's happening right here where the blood is like pouring over this object, like, don't worry about that stuff so much. You got to think that this is a very sterile testing environment. So you'd be surprised how little you need to see of this stuff when you actually like put it into your shot. But it's doing a lot of really nice stuff. Like when it hits the ground, it pulls out really nice, and it flies through the air. It's got like good spec. Like I said before, like it's clearly hitting a wall that's like right here and up here. I just did that to keep the sim going really fast and effectively. It crawls across the ground through its inherent velocity. It's not that bad. This is a lower tier program, but it does get the job done. And the beauty of it is that after you create a blood splat or spray or whatever, you can then render it as a 2D element from the front, from the back, like whatever perspectives that you're going to need, and then you can comp them in 2D just like you do all those elements and essentially make them yourself instead of having to rely on third-party sources like Video Copilot or wherever the hell you're going to get stuff. You know, you could hone in and use the stuff that you make again and again and again and again. So I could render this from the side and from the front and from the back, and I would have that element, change the lighting on it if I need it to be specific, if it's in the dark next to in a hallway where there's like a single light lighting it. It gives you a lot more versatility, and you can do a lot more with it, especially after you've taught yourself how to handle this stuff. Because trust me, people can notice when you use Action Essentials for your blood elements. They can. Anyone can. Just don't think you're fooling anyone, and even if you thought you comped it really, really, really well, trust me, people can spot it a mile away. So I hope this helps someone. I know it was a little bit longer, but you know, generally you can get a whole blood sim up and going in like 10 minutes. I was just taking my time to explain and kind of show you what stuff does and sim it over and over again and blah 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 and all this bullshit. But hope this helps somebody, and if anyone has any questions, be sure to hit me up down below. And yeah, man, it's about time I got a damn tutorial out. It's been long enough, and hopefully I won't make you guys wait so long for the next one. So take care, and I'll talk to you later. Bye.